These are a few problems out of Pre-Calculus section 5.1 on using fundamental trig identities. Problem number 6 gives us that the cotangent of phi is equal to -5 and the sine of phi is equal to root 26 over 26. The first thing we have to figure out is where is this angle located? The sine is positive, so from that I know it's in either quadrant 1 or quadrant 2. And since the cotangent is also negative, it means we're talking about quadrant number 2. So I'll draw an angle over here into quadrant number 2. And the cotangent of the angle is -5. Cotangent would be opposite or adjacent over opposite. So here's our adjacent, there's our opposite. So that holds true with the cotangent of phi. And then it says that the sine of phi is root 26 over 26. Well, let's see, if we continue on with this problem, then using Pythagorean Theorem, this hypotenuse comes out to root 26. And if I did calculate the sine of our angle, the opposite over the hypotenuse is 1 over root 26, which would simplify down to root 26 over 26. So here is our drawing. We've got to find all the other remaining trig functions. In other words, we need to know what is the cosine of phi, what is the secant of phi, what is the cosecant of phi, and what is the tangent of phi. I'm putting them in really any random order. And I'm going to answer these questions by looking back at the drawing. The first one, the cotangent of the angle is adjacent over hypotenuse. That's -5 over root 26. And if we rationalize that, that's -5 root 26 over 26. The secant is the reciprocal of that, so that would be a negative root 26 over 5. The cosecant is the reciprocal of sine, and sine was originally 1 over root 26, so this would be root 26 over 1. If I took the reciprocal of that, it would eventually come down to this. And then the tangent is the reciprocal of cotangent, that's -1/5, or opposite over adjacent. There it is. This is problem number 8 on that same page. Here's what we're given. And the first one is a cofunction identity. The cosine of pi over 2 minus x is equal to 3/5. What that means to us is then that the sine of x is equal to 3/5. We want the quadrant where both cosine and sine are positive. That's got to be in quadrant 1. Here is our angle x. The cosine adjacent over hypotenuse is 4/5. The sine is opposite over hypotenuse 3/5, and we have this 3, 4, 5 right triangle. So what we need to do then is write down all the trig functions, including the reciprocals, and then use the triangle to solve them. So sine of x is going to be equal to 3/5. I know I solved it up here already, but it wasn't directly given to us that way. The cosecant is the reciprocal. Secant is going to be 5/4. That's the reciprocal of the cosine. The tangent is 3/4, and the cotangent then is going to be 4/3. This is problem number 16 from that same page. And it says, as x approaches 0 with that little positive sign, that means as x approaches 0 from the right, what is cosine of x approaching and what is the secant of x approaching? This is a take on a limit problem. So what I'm going to do is draw part of the cosine curve. I don't have to do too much of it. Here's the cosine curve as it's going to the right. What we're supposed to do is analyze the graph as we're coming at x equals 0 from the right-hand side. So as I'm tracing this, the x values are getting closer and closer to 0 as we're coming at it from the right-hand side. And we want to know, what is that y value getting closer and closer to? Well, down here, the cosine is equal to 0. It's getting bigger, it's getting bigger, it's getting bigger, and then we're getting closer and closer to that x value of 0. From this right-hand side, we would say that that is approaching a y value of 1. And then as x approaches 0 from the right for the secant. Now the secant curve has all those vertical asymptotes in it, and we have these parabola-like shapes that are going in opposite directions. So what I have in red is the cosecant curve. And as I'm tracking this one, going from the right, as these x values are getting closer and closer to an x value of 1, what is the y value approaching? Well, it's approaching a y value of 1 also, so the secant of x is approaching 1.